My name is Ali Abbas. I'm the chair of the Second Australian Circular Economy Conference. And this session is the closing session for the conference, the closing keynote session. I'm delighted to be joined today with my colleagues, Professor Duncan Ivison, Deputy Vice Chancellor Research, University of Sydney, and Professor Thomas Maschmeyer, School of Chemistry, University of Sydney. Together we will share with you today a summary of the conference, closing remarks, and the closing keynote talk by Professor Thomas Maschmeyer. First, I would like to do the welcome to country. I would like to acknowledge the Gadigal people of the Eora Nation, the traditional custodians of this land, and pay my respects to the elders, both past and present. I will give now a wrap-up of the conference, a summary of the conference, and I'm delighted to share with you these numbers that show how much interest the conference has generated, how much interest there has been in the topic of circular economy. We have had about 30 sessions or events in the conference, some 34 hours of online and in-person events. We had some 92 panelists and speakers. We had also quite a large number of unique registrations, 685 in total. Of course, many of these registrations or people attended multiple sessions. So this has been quite a tremendous turnout, and I thank everyone for the support and for joining the conference. It is a virtual festival. We embarked on this organization of the conference early on and decided that it would be a conference that is by the people, by the speakers. We wanted to hear from everyone about the developments, the research, the advances in the circular economy, and the work that is happening on the ground out there. And we also invited people from international, from global countries. And we had some 30% of our audience outside of New South Wales. So this has been truly international. This conference is a synthesis between industry, government, and academia. And this shows you a snapshot of the breakdown between of the participation from industry, government, and academia. You can see overall that industry has been also dominating this conference, again, showing us how important this is from the commercial world, from the companies that have attended, and how important this is in terms of how the industry is leading the circular economy progress. The conference started off with a keynote open session led by the New South Wales Chief Scientist and Engineer, Professor Hugh Darren-White. In this session, Professor Hugh Darren-White spoke about how this is about transforming the economy, broadly speaking. And this is quite a large opportunity. The emphasis was on how massive this opportunity is across the board in all sectors. The Office of the New South Wales Chief Scientist and Engineer has recently established New South Wales Circular Economy Network, now called New South Wales Circular. And we had a keynote session also from the first Australian circular economist, Dr. Kame Tang, on Tuesday morning, in which also she further emphasized the need to transition to the circular economy and how we can phase out wastes by doing so. The conference has seen many events, as I mentioned, across different areas. First up, from the role of science and engineering in developing the circular economy, to design thinking, to circular plastics, circular construction, textiles, food, energy, and many sessions were also focused on translation and getting the circular economy theory out of its shell out there into real world practice. So it was across the board in the different industry sectors. One interesting session I want to share with you was this poster session, which we decided to hold in a bit of an experiment in a virtual mixed reality environment. You can see a snapshot here. This is actually a group photo of the attendees during that session. We had 15 posters submitted by research students and about 40 attendees from, again, around the world. And I am pleased now to share with you the winners of the poster session, the 3 student winners. Amira Samat from the University of Sydney, who's working on circular plastics. Yanxi Yu from the University of Sydney, working on extraction of lithium from seawater. Manoj Karakoti from Kumaon University in India, who's working on solid waste and recovery of carbon nanomaterials. And just to show you a little bit of how this worked, I'm happy to share with you, I'm delighted to share with you a bit of a view of how this went. This is the virtual quadrangle. If you've not been to the University of Sydney, this is one of the oldest buildings in the university. And we had built it into this virtual mixed reality environment where the students had installed their posters here. And you can see there's a discussion there happening between students about the poster. And you could walk around virtually to the posters, view them, and have a chat with the students who are standing nearby at the posters to discuss. There's one of the judges walking around. We had 3 independent professors judging the posters, which has been quite a successful exercise, and I thank them very much for all their efforts. This conference would not have happened if it wasn't for my co-chairs, Dr. Lisa McLean from New South Wales Circular, Professor Yong-Sik Ok, Director of Sustainable Waste Management Program at APRU, and also importantly driving this conference alongside me from the University of Sydney, Rupal Ismin, Director of Sydney Knowledge Hub, who was quite instrumental in forging partnership on this conference. Also, the organizing committee, I must thank Sarah Lacroix from Sydney Knowledge Hub, Sandra Malgon, Manager International and Research Partnerships at the Faculty of Engineering, Sally Hill and Laura Carroll from New South Wales Circular, and Kumudini from Korea University from APRU. And of course, this conference has been a success due to the support of many people, these presenters, the speakers, the panelists, the students who have also done quite a lot of work behind the scenes. And I couldn't really list them all here. I'll take too much time, and I thank them all, one and all. And of course, I would like to thank the University of Sydney for its support, the School of Chemical and Biomolecular Engineering, and the support given by Professor Diane Wiley towards this conference. I'm wrapping up now, and here's my 5 things that I've learned, 5 takeaways for me from this conference. Of course, there are tremendous set of learnings. We will be sharing the conference proceedings in the next days and weeks, so please look out for that. We learned that there is a massive circular economy opportunity in Australia on the economic, social and environmental fronts, and many people in the conference continuously spoke of waste as a resource. There has been tremendous progress already in realizing the circular economy. A lot of people told us stories about how they are in their business already implementing the circular economy, already using circular economy principles in the design of their products and processes. It was such a good and fantastic thing to see the development happening already out there. And this is another point to make here. As a chemical engineer, I saw that the circular economy is way beyond the technical, the engineering, the science. It is really about people, the synthesis of networks, ensuring that the circular principles are properly and speedily implemented. Third, a need for collaboration between industry, academia, and government was of essence, and this conference itself has shown that this type of network development, the collaboration, is of big benefit to developing the circular economy. Four, the importance of enablers, importantly, data and research in developing and establishing the circular economy, and we had an important session on data on Wednesday afternoon. And finally, a clear definition of circular economy was lacking in the conference. Many of the speakers, many of the discussions spoke about circular economy in different ways. And so certainly the definition of circular economy was seen to be way beyond recycling. It is not recycling. And the role of design, which was the theme of the conference, also appeared to be prominent in the conference and in the sessions across the 5 days. So the definition itself of circular economy is different for different peoples. It means different things to different people. And I'm looking forward to further interactions to understand how we could together define it for the prosperity of our nation here in Australia. So with that, I will wrap up. Please stay tuned over the next days and weeks. We will share these proceedings, the conference proceedings, and please do reach out to any of the speakers, the panelists, if you have any ideas and thoughts of actions that you can in your business or in your own area towards developing your own circles. With that, I would like to now introduce Professor Duncan Ivison, Deputy Vice Chancellor Research at the University of Sydney, to give the closing remarks for the conference. Over to you, Duncan, please.
Thanks, Ali, very much. I'm sort of giving the closing remarks before Thomas gives his remarks. So don't worry, you're not having to listen to me. Thomas is only a few minutes away. So before I say a few words about Thomas, and I really look forward to his keynote speech, let me just congratulate you, Ali, and Lisa, and Young Sik and Rupo for really a tremendous conference. 5 days. It's an epic circular economy event and a very important topic. So my congratulations to all of you. And it's particularly wonderful to see the mix of participants and audience members from industry, from academia, from government, students. That's exactly the kind of circular intellectual network that we need to underpin the circular economy network that we're trying to build in New South Wales, and I think we want to build globally. Well, I just wanted to say really two things before introducing Thomas. I mean, the first is obviously, you know, given the climate challenge we face today, the climate crisis really that we face today, there's at least two things we need to do. We need to leave more fossil fuels in the ground and find new ways of powering our world and energizing our world. And we need to use less and think of waste, as you said, Ali, as a resource. And both of those are deeply technical challenges, right? They're great scientific challenges, but they're also philosophical, economic, cultural, legal, moral challenges. And it's so important, as you said, Ali, that we are constantly working to connect the different elements of these challenges, that we need not only great engineering, great scientific, great technical insight to these challenges, but we need to make sure we have the right legal systems, the right moral frameworks, the right mindset to change the way we live. We're not going to solve climate change by just flicking a switch, although, you know, new kinds of switches and new things to flick to will be part of the story. So I think it's really exciting to see the concept of the circular economy growing, and the work that is happening here at University of Sydney is something I'm very proud of. I mean, we're contributing along with many other people, but as we'll hear in a minute, there's some very important work being done here at the university. I guess the other thing I wanted to say was, in light of that, I do think universities have a particular responsibility to, and especially universities like ours, a research-intensive, comprehensive university. You know, we teach everything from ancient Greek right through to zoology, and a lot in between. We really need to harness our research capabilities and our intellectual firepower in both our students, our staff, our alumni, to tackle these big, difficult challenges that the world faces. And I guess that's something we have been trying to do here at the University of Sydney, as many other universities have been trying to do. And Thomas has been someone at the forefront of that agenda here. But I thought I would mention that the other thing I think universities need to do is, walk the walk and talk the talk. We need, as an institution, to embrace some of the principles of the circular economy and the kinds of ideas that have been a part of this conference. So we need to look at our own operations. We need to look at what we're teaching, the kind of research we're doing, but we need to look at our own waste production and the opportunities for us to actually embrace some of the principles of a genuinely circular economy. And we're trying to do that through our new sustainability strategy. And Ali himself has been involved in that. Rupal, who's on part of the conference, has been involved in that, and there are many others. So this is really a kind of end-to-end, whole of university, whole of society agenda that we're all struggling and thinking through. And I'm delighted that we're hosting this conference in partnership with APRU and with New South Wales Circular, and the support from the New South Wales State Government and many others. So it's just terrific to see. Well, obviously, in order to tackle these problems, you have to have scientists and you have to have researchers who are willing to engage with industry, engage with government, and engage with the broader community. And I don't think there is a better example of that than Professor Thomas Maschmeyer, my colleague here at the University of Sydney, who really is, I think, an exemplar for the kind of work we need to do in academia and the community today. As many of you will know, Thomas is a professor of chemistry here at the University of Sydney. He's also a serial entrepreneur and a dynamic translator of first-class science into commercial and public good activities. He's executive chairman of Gelion Technologies, this exciting new battery technology. But he's also the co-founder of 3 other companies, fellow of 4 academies, serves on the national board, I think, of at least six journals, and is most recently the recipient of the Prime Minister's Prize for Innovation just this year, and the Australian Financial Review's Award for Sustainability. So I can't think of anyone better to close this important conference and to share some of his insights and work than Thomas. So Thomas, over to you.
Right. Well, thank you very much for the kind introduction, and I'll share my screen if that hopefully will work. Right. Everybody can see my screen? Yep. So thank you very much for the opportunity to talk here, and in a sense, the conference itself, I think, has finished, and it was a major success. So many congratulations to all the people involved. I think especially to Ali, who's been a real true believer in the circular economy from way back. So just fantastic to see that coming to fruition and just growing from strength to strength. I think I've been asked to talk a little bit about translation, technology transfer, translation in general. So what I'll do is I'll use some of the work I've done more to exemplify some of the more general points. So it's not going to be a technical deep dive. It's more a little bit about, look out for this, look out for that. Maybe these kind of approaches work. Maybe that works. Especially, I guess, geared towards the younger researchers or students who might think, well, maybe I want to do a startup. Maybe I want to have a go. So that's the thinking behind this presentation. So I'll start off. Well, I hope. So my screen is not moving. Oh, there we go. So the first thing to do is, of course, to realize that it is not possible to do tech translation as an individual. It's always large teams, and it's the research teams at the Sydney University, but also, of course, the teams within the companies. And as companies mature, as IP matures, then researchers should start to take a few steps back and let the more commercial people take over, and that is usually very well received if you say that to investors, that's your plan. So if your plan is to make yourself redundant, they quite like that. So just a hint there. I want to talk about transformation because everybody says, I want to do technology translation to transform, transform the world, make the world a better place. Some people might want to transform their bank account, but there are better ways than doing technology translation to do that. So how do you think about transformation? So I think it's good, this sort of vision times competence, that gives you the size of the transformation. And of course, grand vision, great competence, will engender a massive transformation. But one is part of a real system, a real world, and markets might experience ups and downs, and legislation might come, might go, pandemics can hit us. So there's also a degree of anxiety, not necessarily the anxiety of the company founder, of the researchers or the team, but anxiety in general. And I think the pandemic outlines that very nicely. So if I want to keep the transformation part of my equation high and assume that competence will not fail but grow over time, or is reasonably constant, how do I deal with anxiety? I have to deal with anxiety by redoubling down on my vision, to make a plan, to give, make the vision even bigger, be more aggressive, be bolder, take your team with you, and force, force success down the throat of reality. So the worst thing to do when markets are trembling and when things around you are not looking so good is to go away into a corner and wait until it's all over. That's not how you achieve transformation. It's about redoubling on that vision. Very important. Circular economy, well, the whole conference was about it, so I won't go into great depth. The batteries that we are making are designed for 100%, close enough as possible, 99.something% full recyclability. So I think if anybody makes any new products, that has to be part of the product design. And I will talk mostly about remanufacturing or reprocessing with our plastics technology, which then allows us to put those products back into the normal chain, the normal distribution chain, to be consumed and then to go around in the circular economy by remanufacturing them. So the process I want to talk about mostly is that catalytic hydrothermal reactor technology, which basically takes low value waste, low value residues to high value products. As was already said in the introduction, really to change the conversation, making waste into not a problem, but into an opportunity, into a resource. And when one goes out and tries to convince the world this is a good thing, it's really handy to have examples which are bigger than lab scale. Now, this is a particularly large example, 10,000 tons a year. I don't think it has to be always that big. But in terms of getting impact and credibility, moving it outside of the lab is a really important thing to then go further, whether it's a licensed deal or whether you're going to set up your own company. So that's really important. So I want to focus initially on plastics, and I think these are the plastics which have just been generated as part of this conference here in this photo, but I'm sure they'll be looked after well. When I go out and try and raise money or get attention, the first thing I have to do is to really grab the audience. And this is an unfortunate statement, but it's true, and it does grab the audience. If current trends continue, our oceans will contain more plastic than fish by 2050. And to me, that is totally unacceptable. Also important that such a statement is verified by someone else than you, right? So that, in between the eyes kind of statement is very important to generate that interest and get people to really listen. And then you need to outline what you're going to do about it, or in a sense, what's been done right now. So in the case of plastics, there's physical recycling, but we all know that's only less than 10% of plastics are currently physically recycled. The rest is either burned, it's put into landfill, which are both not great options, given that we have done a lot of work in the crude oil refining to make the plastic. So all that work is just goes up in smoke or just gets buried. And the worst, of course, is that a fair amount of plastic ends up in the environment, especially in the oceans. And therefore, if I can give that waste a value, that will change the behavior of people. So that is what Duncan was saying. It's about a society-wide approach, not just a technical better mousetrap. So if this is the current picture, what kind of technology have I got that improves this picture? Another really important point is, if something works in the current situation, don't step on it, leave it, or even encourage for it to grow, so that I will leave the physical recycling, as it is, because otherwise you're starting to split the coalition of the willing in terms of, we want to change the world, make it a better place, if we start to compete against each other. So in terms of how you frame what you do, whatever it is, keep the good new stuff and see that as complementary. However, usually there's a lot of stuff left over where one's technology can interact with. And so what we are saying is, we'll take the waste, we chemically recycle it, and make it into a product, and keep the carbon in that circular economy with the minimum amount of carbon released to the environment, to the atmosphere. And so it's complementary, and the stronger physical recycling is, the less chemical recycling I need to do. However, that currently is about 90% of plastics aren't chemically recycled. It's a rather large market, so I'm not worried about that. So then, what's the technology? You've got to put that into simple ways that people can understand, that don't really have a lot of scientific or technical background. Flow diagrams are good. So I'm taking my plastic waste and I mix it with a little bit of water, about 25% water, 75% plastic, and it goes into a magic reactor. And what happens is, initially I make some gas, as well, of course, as liquids as my main product. Now, are these gases a problem? No, because I can use them and boil the hot water that we use to actually process our plastics. It's supercritical steam. It's steam that is so compressed as to be able to dissolve things. So it's water as a gas, but it can dissolve things, but it can't dissolve salts. It can only dissolve oils. So it's completely opposite to normal water, and very attractive from a chemistry or chemical processing point of view. So that's what's inside the reactor, and the gases we actually burn on site to generate this high temperature, 440-degree water at high pressure. So we actually run the plant on the waste itself, which is a sort of cool thing to do. Then we get out our plastic crude, and we have a lot of filler materials in plastics. So if you look at a Coles shopping bag, the white is basically titanium dioxide and chalk. So there's a fair amount of non-carbonaceous material which drops out when you do the recycling. So this is what comes out of our plant. So nice and visual, everybody can understand it. It goes from a thin liquid, like petrol-y, sort of looking down to a wax. One doesn't need to be a scientist or engineer to understand that. These 4 streams I'm showing here, they come out in a continuous distillation column from our process. They look like it does in the picture up there, and I can sell them and I can interact with them into the circular economy. So the naphtha just gets cracked to ethylene in a conventional refinery to make polyethylene, so more plastic. And then the other bits and pieces, the waxes and lubrication components, can be used as is. Industrial waxes everywhere. And the remainder is a bitumen additive, and we've actually built a bit of road with that bitumen additive, and it makes the bitumen perform even better. So that's a really nice set of products. And the inorganics, what are we going to do with them? They can go into as filler materials into brickworks or cement works. So that's all very straightforward. We are using water to process, so we have processed water. Most of that gets recycled, so we're not a net water user in a very significant way, but we need to keep salts and whatever to a certain amount, so there will be some bleed, and that goes into normal municipal kind of water treatment plants, no problems there. So you can see the technology may be complex, but it's reasonably graspable for non-specialists with such a sort of, almost Sesame Street-like kind of picture, but that's all you need. And when you have deep due diligence, you may need something else. But we're talking about circular economy, and it's not just good to say, well, I've got a new fantastic technology, make the world a better place, and if everybody just did the right thing, things would be fantastic. Just do the right thing. The appeal to nobility is really good, the nobility of the human species, but the appeal to avarice tends to have a lot more impact. So let's examine the avarice part a little bit. So the circular economy, this is what it will cost to take $2 billion to basically take 50% of all of Australia's plastic waste and repurpose it into the circular plastics economy. $2 billion. Now you may think that's a lot of money. It's 2,000 million, but let's have some comparisons. What else costs some money? So it is the cost of 1/4 of one of the 16 submarines we are paying France to build for us or with us. And I think if I go out into the streets and ask the average punter, hey, do you want 50% of all of Australia's plastic waste to be recycled with our technology, or do you want 1/4 of one of the 16 submarines to make it really happen there? I think they're not going to go for the submarine. I think they're going to go for the thing that creates jobs in regional centres all over Australia, improves the environment, etc., etc. So I think that's the first point, and that tends to make people sit up. But then, is this $2 billion just something that is like charity? Is this just a cost for doing the right thing? Let's calculate this through. So we are making in Australia about 3 million tons of plastic waste per year, and if I take 50% of that, well, maths is easy, 1.5 at 1 million tons. So if I take my 80% liquid yield, which is conservative, we make a little bit more, that translates into 1.2 million tons of those products I showed you, which if I say it's all oil, translates to about 8.8 million barrels. So in Australian dollars, it's about, I think, $58 now, but forgive me, let's do 60. That's basically $500 million worth of products a year. So that means after 4 years, I've got my 2 billion back. So given the plants are designed to run for 20, 25 years, hey, this is a really good return on investment. So it's not charity, it actually makes sense to do this. And we're rolling this out worldwide in Canada, in the UK, in Germany, and there's some challenges in terms of environmental legislation in Australia that slows us a little bit down here, but we hope to be able to overcome that. In Australia, the issue is I need to have a reference plant that is run for 2 years somewhere else that has full emissions data. Otherwise, I'm not allowed to build one. Given it's a first of a kind, I can't build it in Australia. That's why we're building them overseas, but once we have the first one done overseas, we are allowed to build them here as well. So yeah, all of this together will grab, if you have a technology, your investors' attention. So have some audacious kind of comparison with something else out there, come up with a really simple way of saying you're going to make a lot of money, and then, come up with a sort of projected internal rate of return. And I think you have, in most cases, you have them on the hook. A picture of our UK plant. Our technology is just the orange bit there, the KHDR, so that's quite small. There's some holding tanks for the product. A lot of the green stuff, those green buildings in front, are extra sorting facilities, because in the UK, unlike Germany, the rubbish is sort of a bit rubbish, and it needs to be sorted to make sure all the lawnmowers and engine blocks or whatever are taken out of the sorted plastic. In Germany, that is already pre-sorted, and it would just be the orange bit with the holding tanks for the products. Equally, Australia has a higher standard of sorting, and it'll be a much smaller enterprise. Now, I've said all the stuff, and people will still go, if you're in an investment kind of situation, well, has he just smoked something? He's maybe just a good salesman. How can I check this? Has anybody else looked at this? So it's always really good to have something like that in the back of your pocket. So in our case, we've won the global packaging prize from more than 70 entrants around the world. And it's called auspiciously the FlexPack Recovery Challenge Award from the Sustainable Packaging Coalition, which is not a household kind of award, right? And initially I was not too excited when I was told we were going to go for this, but the expert panels, which then chose the technology that won it, come from these companies. And you think, well, okay, so if the experts from these kind of companies say this is the best in the world, it's probably worth having. So that gives the that credibility that people then feel comfortable about. We can also switch to biomass waste. So in Canada, we are looking to interact with the largest pulp and paper mill in the world. 6 million tons of trees sustainably harvested. For every tree they fell, they plant 10 new ones, and the cycling project's lifetime is about 100 years, 150 years in terms of the forest. So it's all very good and green. And what we can do is we can take wood. So here's just an example of sawdust, and put it through our process and make it into an oil. And just for another sort of hook, it's the same amount of chemical energy if I were to burn either of these vials. So we're really densifying that energy, and we're making it liquid, so we can blend it, we can refine it, we can do all sorts of things with it. So biomass is a great one, and if I put it into a general refinery stream, that don't need to do anything to the refinery, just put it into what's called straight run gas oil. Then you see, as we add our bio oil, it gets a bit darker, and you may think this is terrible. But red wine is dark because there's some molecules in there which are really, really light absorbing. So with a little bit of conventional upgrading, it all looks perfect. In fact, the quality of the stream that comes out is enhanced by adding the bio-crude oil. It's actually more valuable than not. So we have letters from all major oil refiners that their refinery operators are allowed to accept our oil once we've made it at scale. So this is where it goes in, and that's the wonder from down under, not us. Somebody else said that. We obviously like it, and this is our power. This is our demonstration plant in Australia, in the right bottom corner, going all the way to Canada. So very exciting, making the world's biggest bio-crude oil plant over there. So now more general points. What I've shown you is really underpinned by the title of this slide. From strong basic science, all else flows if you do technology. If you're an engineer, you still need to anchor that into some strong basic science and then take the next step in translating. If you're a scientist, you need to look for an engineering partner who helps you translate that basic science into some engineering design, right? But that really the real depth of intellectual endeavor and quality is super important. You can't wing it. You will be found out by reality if you wing it. It's got to be really, really good. Then the other bit, which has nothing to do with science or technology, it's working the room. It's important when one does these things and you have a company or you want to get a license deal, you've got to talk to companies, you've got to talk to people who you don't know, etc., etc. And you don't really know necessarily who to talk to, because there's quite a lot of people around the world, different financial people and legal people and brokers and strategic investors and high net worths and whatever. So how do you find out? Well, you've got to talk to people. So you've got to work the room, as it were. But you've got to do it in a way that you genuinely want to find out about the other person. If you do it to clearly want to have an advantage for yourself, it's going to be painful. It's painful for you and painful for them. So best is to be self-deprecating. Don't take yourself too seriously. Find out and be excited about what they do. And, if it's a bit boring, just to make them feel good, pretend to be a bit more excited and move on, the moment you can get out of there. And just do that. And that can be a struggle for some people. And then if you're not good at it, make sure you partner up with somebody who is, and then they can do that for you. It's an essential activity, and you've got to do it until you vomit. But it can be a lot of fun. often I'm asked, how do you do it? You know, what's your special sauce? And in the context of what I just said before, you know, I would answer, if somebody asked that question to me in such a working the room situation, I would say, looking pensively at a prop, as I'm doing here, is a key skill, right? Unless you can look pensively at a prop, you shouldn't even start thinking about a startup, right? This is your key skill, practice it in front of the mirror. And then they'll relax a bit and you relax a bit and you can talk what you actually want to talk about. What is really important is there's not one way. If anybody tells you there's one way, sort of walk away in a polite fashion. There is just not one way, right? And you know, I always say, no self-help book starts with saying, you know, one day I went to the bookshop and I bought a self-help book. So there are lots of different ways for different people, different circumstances, different technologies, etc. But there are some similarities. So it's really important for the academic, for the scientist, for the engineer to understand some business basics, just so you can talk a little bit, like, you know, internal rate of return, discounted cash flow, EBITDA, you know, IP bytes, whatever. Yeah, those sorts of things you need to, you know, convertible notes, special favorite. You need to understand what they are, but you basically can look that up in the book or online over about an hour or two, and you know, you can talk the talk a little bit. Conceptually, it's really important to strive to succeed and not just to avoid failure. If you strive to avoid failure, it's sort of the same, but it's really different. And once you become so risk averse that you're constantly trying to avoid failure, you've already failed. So striving to succeed and just, you know, as I said, forcing success down the throat of reality, that's what you have to do. And you can't do that by yourself. You have to do it through relationships. You have to do it in teams. So it's a really important, obviously, be clever, but I assume that everybody, you know, is clever and visionary, given that they've clicked onto this talk. So that's a given. But you also need to have a high emotional, you know, intelligence in order to be able to form those relationships and you know, grab people to walk that walk with you. And that leads to speaking to the other party's needs, and at the end of the day, develop a common vision, right? Because if you want to get people to go with you, you need to have that common vision and the common way in which you're both, or you know, you all are motivated. And that can take some time, and it can have some rough conversations. But then once you hone in on that, that's a really strong team that you've got. And you walk with them, you know, through fire, right? Because a lot of the time it's pretty dicey, and you're in the intensive care unit of startup land, and you gotta make it happen. So you gotta have a team that's really welded together. That is clearly given by a win-win, and that team is not just your tech team; it's also the investors. It might be the university, you know, whoever else is in there. So that has to be the aim. And in order to achieve that, you need to display genuine and authentic enthusiasm, which I'm trying to do via Zoom, which is sort of hard. But anyway, you got to do that, because the bullshit meter of people who do this professionally is extremely accurate. They smell bullshit a mile off. So it's got to be genuine. It's got to be authentic. Equally, if you don't know certain answers to certain things, that's just okay. If you come up with an answer for everything, people start to go, oh, not sure about this one. That's a bit of a slick kind of performer. Genuine and authentic, important. Having skin in the game, very important for the investors as well, because, you know, if they hurt, if it doesn't work, you should hurt as well. So reputational skin in the game, maybe you know, some shares or whatever that you would lose, or, you know, certainly your time would have all been wasted. Something that shows them that, yes, you share that journey of risk with them. It's not just you having a go, trying to do something you're interested in. It has to be more than that. And then, you know, in terms of, I guess, example of being on a dance floor, don't be the guy who's really desperate. Got to be, you know, relaxed and display a deep competence, because people will respond to that. They will say, well, this person doesn't actually say he's desperate for my money or desperate for my attention, so maybe I want to give him some attention and some of my money. it's sort of, that is a much better way of going about it. And yeah, do media and do PR until it hurts. Any opportunity to get in the paper, any opportunity to do a launch event or something, any opportunity to have a spot in a conference or in some sort of industry meeting, you've got to do it. Even though it may be at times, you know, the media tart sort of thing happening, it is just what you need to do. And if you want to embark on this journey, it's one of the, you know, one of the costs, one of the price you have to pay to do that. However, you know, it can be lots of fun as well. And if you have a look at the picture there with the whole team, with our launch, that was good fun. So I'm not trying to make it too grim, but sometimes it can be a little bit, you've got to jump over your own shadow a bit to do it yet again. But it has to be a constant part of what you're doing. And finally, really an ability to weave the dream and get people with you, and keep weaving the dream and keep promoting the vision, especially when anxiety is around. As I said in the very beginning, you are the rock in the sea as the founder, if that's what you end up being, and people will look to you, and you've got to just keep at it. And over time, you will be successful. Thank you very much.
Great, thank you, Thomas. Fantastic story about your experience and the, yeah, really the extraordinary variety of things you've done and the things you've learned on the way. We've got a few minutes for questions, and you can just put them into the chat function or the Q&A function if you're sitting on Zoom. And I thought, I mean, look, I thought I'd ask something, and it's sort of there in front of us on your last slide, but when you think of your, you know, experience with Lacella and with Gelion, I mean, Gelion, sorry, what were the biggest obstacles? I mean, obviously you had to do great science, and there's a kind of inherent challenge there, but what were probably the biggest hurdles that you faced that you learned kind of the most from? Yeah,
so the biggest hurdle is always that translation into scale. That's the biggest hurdle. So at the laboratory scale, we've built, you know, batteries which were just world beating, you know, on just about any criterion you could possibly think of. But the electrode size might have been just a square centimeter, so a really tiny one. And once you want to go and say, well, I want to build a battery for a solar farm, the battery blocks become somewhat larger, and then the volume of battery blocks becomes rather large, and then all of those things change. And every time you need to verify and validate the design through lots of testing, sometimes 3 months, 6 months testing, and factoring that in is a really different kind of life than if, as a chemist, you know, make something and maybe have a reaction that takes a week or two and purify it and I'm done. One has to plan for really expensive capital investment in terms of testing equipment, in terms of just materials to build all that stuff, and then have them sitting around, you know, being tested, etc. So that is something that most people from academia, unless I guess they study how to do this, would be really unfamiliar with. The amount of time and effort and money it takes to go to scale.
And that's often where, I guess, certain issues you don't expect get exposed, right? And right. Certain sort of vulnerabilities emerge.
Yeah, when you have, you know, some site reaction of 0.01%. Yeah. If it's a thimble, well, yeah, you don't see it.
Who cares? But if it's
you know, if it's 10,000 liters, suddenly it sort of turns a bit dark, doesn't it?
And then just one more from me. I mean, just in relation to that, I mean, I remember this article when you published it, and you know, you and I have been in situations where this whole theme about why, you know, is it harder in Australia to do this kind of thing than other countries? Is that true? And if it is, you know, what would you know, what do we need to change or fix so that, you know, young researchers out there who might be listening going, hey, but everyone tells me you can't do this in Australia. Is that true?
Yeah, so there is a misconception I find in Australia, in the sense that people say, well, the academics aren't active enough, and you know, there's not enough money around, and nobody wants to really have a go at that. That's actually not true. That's quite good. And there are a lot of quite visionary high net worth investors and so forth. So to get the first, you know, 5-10 million, that's not the problem. The issue comes somewhat through regulation. Regulation in Australia is extremely conservative. And people who are applying the regulation are aware of that and asking politicians to change it. And then that process takes a very long time. It can be often bogged down in partisan kind of views, existing stakeholders, etc. So that is really an issue. And the philosophical view of we are not picking winners. Now, of course, we shouldn't pick winners for existing technologies because the market should do that. But if I'm asking the market to judge something really new, it's not what the market does best, right? The market is very short term. So other countries might have a more strategic view on saying, well, we are supporting new technology that looks good by some criteria, and we will invest in that strategically through preferential purchasing agreements, through manufacturing grants, through whatever, to build it up. And once it has grown to a certain size, we let it go, leave the nest, and see whether it can survive in the big wide world. That is really, really not as strongly done in Australia compared to other countries like Japan and Germany or China, for example.
Holly Chung has got a question up on the chat. She says, as an academic, can you describe the experience working as an entrepreneur versus working with big corporates?
So I never worked as an employee of a big corporate, but only as a consultant or having big corporates as clients, I guess. So the academic has a reasonable degree of freedom in terms of what they choose to do and how they choose to do it. Once it becomes connected to large enterprise, large industry, that freedom gets very much reduced, and it's really about a specific thing that you've agreed to deliver at some stage for a certain budget and at a certain point in time. And being clever or just having some extra papers or new insights which are really interesting, that all doesn't count. That's all counts for nothing. It has to be the specific delivery for a specific amount of money in a specific time frame, and that is quite a difference between academia and companies. And the larger the companies, the more narrow the definition.
Okay, are there any other questions that anyone wanted to ask at this stage before we wrap up for this afternoon? It's been a terrific presentation. There's something here from Shuying Song. Thank you, Professor Maschmeyer, for an enlightening presentation. As we come into yet another season of holidays, of which gift giving is common and at times obligatory, do you have any thoughts on how we can challenge societal norms on not over purchasing?
Wow, right. Yes, so this is in a sense a somewhat a critique on capitalism, and I'm very happy to have that because I think our idea of having an endlessly growing world is not a way to go. So from that point of view, we could talk for some time. Yeah, over purchasing, I think quality, purchasing quality is good because quality means there tends to be more work incorporated in the particular piece that you're buying. And I think that gives them salaries to more people rather than having something really cheap done by a machine. So focusing on those kinds of gifts that contain a lot of units of work. To quote, I guess, one of my countrymen from some time ago, giving the unit of work appropriate value is the way to go, and that is mostly done by high quality products, in my view, which are bespoke. And it could be just a lovely card that you write to your family member and draw something on it.
Yeah, and RuPaul's just jumped in saying we need to move to a culture of regifting, second-handing.
Yes. Oh, now you've got my secret for what I do at Christmas.
I know what I'm getting from you for Christmas. It's what I gave you last year. Look, Thomas, thank you so much. I'm going to hand back to Ali now to finish things off. Thanks
very much. Thank you.
Well, what a fantastic way to finish the conference. Thank you very much, Thomas, for this fantastic presentation. A lot of interesting and important insights, and a lot of these challenges many academics and researchers, of course, grapple with. So it's really good to share that experience. Thank you again. And thank you, Duncan, dearly for chairing this session, the closing session, and for your closing remarks. And with this, I would like to finish the conference, and I want to thank everybody again who has attended the conference. And I hope that this has been a useful 5 days for a lot of you, and that you've taken something out of the conference for yourself.